A Bernoulli or binomial trial is an experiment with a set of identical trials, each with only two possible outcomes. So a Bernoulli or binomial distribution is a common discrete probability function that has the following qualities. It has a fixed number of trials. Only two outcomes are possible for each trial, a success or a failure. The probability of success is the same at each trial, and the trials are independent. This leads us to the binomial probability. That's the probability of getting X successes in a binomial experiment with N trials with a probability of success P for each trial. So that may sound really confusing, but whenever we go to Excel to calculate these, those are all pieces of information you're going to have to get it. You're going to have to give it how many trials are we performing, because remember, there's a fixed number of them. What is the probability of success for each trial? And how many successes specifically are we looking for? Like how many out of how many trials? We also need to understand and give the Excel the information about whether we are looking for something cumulative or not. So cumulative means when you're looking for the probability of all number of successes up to a certain amount. And that will make more sense when we actually do an example. Okay, so here's our example. Suppose that 12% of a certain population is left-handed. We decide to take a random sample of 50 people. And it says, why would this be considered a binomial distribution? So let's see, does it hit all four of these criteria? So are there a fixed number of trials? Yes, there are, because we're taking a random sample of 50 people. So we're going to take 50 people, and then at the 50th person, we stop. It's a fixed number. We wouldn't continue anymore. So we've got fixed trials, or a fixed number of trials. Okay, so we hit that. Are there only two outcomes possible for each trial? Well, yes, because when you pick a person, when you choose them randomly, they're either left-handed or they're not. So you either have a success or a failure for this particular situation. So you're either left-handed or not. So two outcomes. Is the probability of success the same after each trial? And that kind of couples with number 4, are the trials independent? So if we are randomly sampling people, this is key here as well, then what if I choose person number 3 and they are left-handed, that does not at all affect whether person number 4 is going to be left-handed or not, because these people are not related in any way. It's totally randomized. So because they're independent, check because of random sampling, then that means that every single time I pick a person, there is a 12% likelihood that they are left-handed. So it's always a 12% probability. So we hit all of the criteria. Excuse me. Okay, so we hit all those criteria. So now we're going to use Excel to find first the probability that exactly 9 of these sampled people are left-handed. So when we go to Excel, I'm going to write out the command we're going to use. We're going to use equals binom for binomial dot dist. And what we have to give it is we have to give it the number of successes that we're looking for. So in this case, 9. Out of how many trials? In this case, 50. What's the probability at each trial? Each person that we choose has a 12% probability. So we put that in as 0.12. And then this last bit of information has to do with the cumulative or not. So we're looking for exactly 9, not everything leading up to 9, not the probability of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That would be cumulative, everything up to this certain amount. So for us, we're going to say false, which tells Excel this is not a cumulative situation. And then we're going to hit enter. So you have that's also on your Excel commands document that I've created for you, but I didn't pull that up right now for this video. I'm just going to type it in, and I wrote it there. So let's see, I'm going to write exactly 9, and underneath that I'm going to type in equals binom.dist, and then notice it says the number that we're looking for, successes, so 9, comma, trials is 50, comma, the probability is 12%, comma, and then it asks you cumulative or not, and it kind of reminds you here your options are either true or false. So for us, we're going to say false. No spaces between your commas or anything like that. Hit enter, and it gives me the answer. Usually 4 decimal places is the accepted amount of rounding, but do check your directions on your problems. I'm going to keep this as 0.0684, and that's how I'm going to type this in, or that's how I'm going to give the answer, 0.0684. Or if I want to think about that, there's about a 6.84% probability if out of 50 randomly sampled people that exactly 9 of them would come out left-handed. Okay. What's the probability that at most 9 of these sampled people are left-handed? At most means everything leading up to 9. So basically it means less than or equal to 9. So the only difference in this command this time, we're still looking for 9 out of 50 with a 12% probability each, but this time this is cumulative. I'm going to type in true. So what's the probability of getting 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, any of those being left-handed? So for at most 9, yeah. I type in exactly the same. Oops. Except I just changed that very last value. So 9 out of 50, 0.12, true. Make sure you spell it correctly. I'm having trouble typing right now. So look at how big of a change that made. There is a 0.9292 or 92.92% probability that you will get something up to 9, but not over 9. Okay, so it's very likely that out of these 50 people, you're going to get 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, somewhere in there, people coming back left-handed, something less than or equal to 9. What's the probability that at least 10 of these people are left-handed? So at least 10 is the same as saying greater than or equal to 10. Now the trick in Excel is that it won't do greater than or less or greater than or equal to. So you have to do a less than, and then you have to subtract. Basically, you have to do a complement rule. So the other way to think of at least 10, because we're talking discrete, if you are greater than or equal to 10, that's the same thing as saying greater than 9. If I'm bigger than 9, then that means I'm 10 or more, because we're not counting any of the decimals between 9 and 10. So those are two different ways to say that. So what we need to do, this is basically the complement of part C. So we're going to subtract. We are going to just say, well, this is everything else. So this is 1 minus 0.9292. And if you subtract that out, you get 0.0708, which is 7.08%. That's the only way to do a greater than probability like this. You have to recognize what it is the complement of, do that specific. So if I hadn't done this part yet, I would have to go ahead and calculate that at this point and then subtract. So read your questions very carefully to see if you're going to need to do the complement rule. What's the probability that none of these people are left-handed? Okay, if none of them are, then I'm going to be using equals binom.dist no people out of 50 at a 12% probability each. And there's really no way to be cumulative, so because there's no way to count up to, there's nothing below 0 to include there. So let's see, 0 or no people. No people out of 50 at a 12% probability each. Not cumulative. So let's see, 0.0017 rounded off there. Or a 0.17% probability. So look how unlikely it is that if you randomly choose 50 people, it's very unlikely that you're not going to get anyone at all in that group of people who's left-handed.